Hi, Walter here from World Civil. This is a continuation video from the last one in which I was showing how to migrate a vanilla Golang smart contract in Hyperledger Fabric to Convector. In this opportunity, what I'm going to do is to continue this smart contract with the same model and the same controller, but I am going to take this code and bring it to a Node.js backend. In there, I'm going to make all the functions. The only difference is that instead of calling the ledger, I'm going to call the API nodes which come with the Hyperledger Fabric network. For the sake of simplicity, I'm going to use a Geoman generator to create a new project inside of this packages folder, which is going to work as our backend. So what I need to do is first install the generator from Geoman. So I need to do npm install generator express no stress, which is the name of this generator. Now that I have it ready, what I have to do is to create a boilerplate for my project. So I have to do yo express no stress TypeScript, and I'm going to set the name to my app. So it is going to bootstrap everything. It's going to ask me if the description is fine. For me, it works. This works. And it's going to build everything that I need in here. What is the most important part is this server folder, which contains an API with some routing, and I'm going to reuse that to include my structure from my model and my controller. To see if everything works, I'm going to focus now on the backend. I have to run npx. If you have npx, or you can do lerna directly, run compile scope my app. npx is a way to manage packages in your development, so if you don't have it, I recommend that you look it. It contains really interesting ways of doing things. And I'm going to run npx lerna run, and now I'm going to start this server to see if this is working. So while this starts, what I'm going to show you on this video is the version video of this post in which I am showing how to create this backend with Node.js for Hyperledger Fabric. As the post says, it is a continuation from the previous video. So now I can go to localhost to see if this is ready to start. Let's try this again. It says that it is starting. Okay, let's try without debugging on. Let's try just the depth. Okay, so it's running now on port 3000. Let's try this, and there you go. We have this application. This is a simple HTML render from this server, but what we really are going to focus is on the API part, not in the front end. This is just to see if everything is installed correctly. So there are a few important files that you need to check out. Since we created this project with Hurley, Hurley already handled everything that you need for your setup of your blockchain network. So your backend application is going to make transactions on behalf of an user. So it needs certificates to communicate, such as TLS and so on. It also needs certificates to authenticate, for example, to know that it is allowed to make a call to a chain code. And it also needs some files regarding where are the nodes, what are their addresses, and so on. So every time you create a project with Hurley, it creates a set of configuration files and some folders to host all your components like certificates. So for example, if you want to know what is the topology for your blockchain network, in here you can see there are the network profiles which you are going to load to Fabric SDK. And as I was saying, pretty much what it says is here are the nodes, you have to communicate with these certificates and so on. So Hurley automatically creates two kind of files, one that is called inside Docker and one that is called just network profile. The difference is that if you run a container inside of the same network that the blockchain is running, you can communicate differently than how you communicate from your host machine. In this case, a folder that is fairly important for you are these HFC folders. Those include all the private keys for the users of your blockchain network. So for example, if you are running your application with organization 1, then you will need, for example, in this case, these certificates. The same if you are going to use organization 2 or organization 3. All of this is self-generated. So it is important to know the structure of this folder, but I'm going to explain you how to consume them and how to set them up in your Node.js application. Just as a heads up, this folder is created by default inside of your home folder. In this case, for my computer, it is users/Walter/Hyperledger Fabric network. In there, I have all the information needed. But what we can do right now is import inside of this Node.js server. We're going to import the chain code so that I don't have to type everything again from scratch. So what I have to do is run again npx lerna add, and I'm going to tell this what is the name of this project. It is called carcc. So what I want to include in this case, it's the server, so I'm going to tell this carcc at the scope that is called my app. There you go. So now we have imported to our backend our chain code. So let's check this, and there you go. We have to install some dependencies that our backend will need. These are the SDK files and packages and libraries. So I'm going to do npx lerna add, and I'm going to add the Convector adapter for Fabric, and the scope is going to be my app. This is going to allow me to communicate with the backend. I think I typed something wrong in here. There you go, Fabric. There you go, and we have another dependency that we need to add. In this case, we also need the adapter for CouchDB. CouchDB is a database that a Fabric network creates by default for you to query the database, so you don't have to make complex queries directly to the smart contract. I think I missed something again. There you go, CouchDB. There you go, and the last two dependencies that I need to add them like this, are the Fabric client. The Fabric client is the official SDK from the Hyperledger project. The reason why I have to add them like this is because those are peer dependencies. The great part of Convector is that it doesn't abstract everything. It still lets you use the default parts. So different from something like Composer, you can use native Fabric features, and what Convector does is improving the rest of the workflow. But in this case, I'm going to use the default SDK that the Hyperledger project is providing. There you go, and I will need to include also the CA client, just in case. Oh, sorry, I typed this wrong, like that. There you go, so I have pretty much everything that I need. There's only one extra fix that we have to apply in this case, and it is installing byte buffer. Otherwise, you will get an error in your backend. So let's add the types for byte buffer, because we are using TypeScript and we want this to read the dependencies well. So there you go. Now we have pretty much everything. Since we are using experimental decorators, we are importing in our my app the carcc package. So if this server does not support experimental decorators from TypeScript, it's going to break. So what I have to do is to go to this tsconfig file, and inside of the compiler options, I will need to include experimental decorators and set it to true. So like that. And this is everything that we need for now. So to make it easier to configure everything, I will need an env file. So let's go in here and I'm going to add some extra fields in here. Those are the default that this Yeoman generator is using, but I need also a key store. I also need a user cert. I need a network profile. I need the channel to which I am connecting to. I need the chain code name. I need the CouchDB database and the protocol. So these properties are mapping out to the folder that we saw earlier, in which there are all the certificates and all the configurations from the blockchain network. So this way I can upload them to the SDK in an easier way. So the first thing that I will need in my code, which is specific to Convector, is to create a file that is going to configure all the SDKs for me. So if I get in here and I create this that is called selfgenfabriccontext, this file needs to include some basic code. It is almost always the same, so I can go to the post that I'm referring in here and I can copy all of this code and paste it back to my code. So as you will see in this class, it is taking the values from the env file and it is going to include them to the SDK. For example, in here it is taking the key store, it is adding the private key value, it is creating a client. This client comes from the Fabric client, so it is the official client that I am using. I'm going to inject this to the Convector adapter that is going to connect to the blockchain. Like this, I include the user, I include the MSP ID, and that's it. I have, with this, now I have communication with my server. With this file ready, I have a generic way to communicate with the blockchain, but that's not really what I want. What I want is to go through the car controller that I created in my smart contract. The main difference is that when I communicate through it in my Node.js server, I want this to send an HTTP call to the Hyperledger servers. So I'm going to go to my server again and I need to create a file that is going to be called smart contract controllers, and I'm going to create another file that is going to be called smart contract models. These two files are going to take what I just configuring here with this adapter, as you can see, and I'm going to add it to the controller. So to avoid typing everything from scratch, I'm going back to the post that I showed earlier. I'm going to copy this and I'm going to paste this. So what I have in here, let me just solve this dependency name that it looks like it's differently typed. What I'm going to do in here is I'm importing this self-generated context, which is this file. I'm going to get the client in here. I'm going to bring an adapter to life, and I am injecting this to this car controller client. This is an important part. The car controller client, it's a file self-generated when you package the chain code, the smart contract, that is located in your chain code project /client. So as you can see, if we go to that route, we can see this folder called client, and it has an empty version of your controller. It's the same functions, the same parameters. The main difference is that it allows a different adapter layer to be injected into this. So it is important because when you are running in your blockchain, you're communicating with the ledger. When you are running in Node.js, you are communicating through HTTP communications. So it is going to receive as a parameter an adapter, and this adapter has all the configurations of your network. In this case, as you can see, we are injecting a Fabric controller adapter with all the settings, and as soon as this receives this and this initializes, I can return a car controller client. So if I import this car controller somewhere, I will have a controller version with the same structure as my chain code. The main difference is that now it knows how to communicate with the blockchain. So another thing that I have to do now is to go to the smart contract models, and I'm going to do the same. The difference between models and controllers are that the controllers use adapter ledgers and the models will use base storage. The base storage, it's telling the server, okay, I need you to communicate to these specific places. Those are the roads. As you can see, those come from the environment file that we already created, and it is mapping our network. So like this, now we have a smart contract that will also communicate to the blockchain when we call it. So just like that, we have reused the structure from our blockchain project, from our smart contract, to be implemented in here for our project. And a small fix that I have to do for this specific geoman generator for this Node.js in TypeScript backend is to fix the Swagger API definition. So if we go to this API YAML file in this Swagger, what I need to do is to replace the contents of this one with the one in the post. I will get the raw version of this. I'm adding a new things. Mainly, I'm adding the possibility to include a put transaction for the update, which is going to be the change of owner. But I'm also telling the Swagger that it will receive this structure, which includes a make, a model, a color, and an owner, so that it won't throw me an error when I include them. We'll close everything, and we have some endpoints already published. As you can see in the routes, it says that it's going to be hosted on API version 1 examples, and it has this examples router. What I need to do is to go in here and check this out. So we can see here it has a post for a create, to get all, it get by. As you can see, it looks really similar to our smart contract. It's only missing a put. I'm going to put in here this function, and I'm going to tell this, yeah, when you do a put instruction, you have to do it like this. So I'm telling the router that when it gets all these verbs, HTTP calls, it has to route them to this file that is called controller in here. So it has some example services. I don't really need this one because I'm going to use mine one that will be calling the blockchain, so I can erase this safely. I just need to include here an extra one that is going to be called update. Now I will start to reference our controller, this smart contract controller that has been injected with the Fabric context, so that when a request gets in here to our server, it will translate and call the request to our blockchain network. So what I have to do is to create a controller. In this case, it has to be initialized. So I will do something like this, car controller. As you can see, it comes from my smart contract controller, which already has injected the communication to the blockchain. So I'm going to initialize this like this, and I will extract all the results in here. First of all, this has to be asynchronous. There you go. And I will need to extract the results, so I will do something like this. Controller dot get all, query all, and I will send the results. rest.json results. There you go. And now what I am doing in here, I need just to make this function async. I'm telling this, go and get this already configured controller that is mapping to the blockchain, call the query all, bring all the results, and return them as a JSON. I will do the same with all of the rest of the functions in here. The get by ID, I will need to do something pretty similar. I need to turn this into an async function. I will make this call and return actually a promise. And the main difference in here is that I'm going to call this through a query instead of a query all. and in here I'm going to pass the request that param so that I can extract the param that is coming from this with the route. As you can see in the route, I'm getting this ID. Oops, I missed this. This had to be update. I'm getting this update. Sorry, here this update, and in here this is the ID, and it is going to call by the ID function that is receiving this parameter. And now what I have to do is just return the item as well, just like we did before. In this case, let's call this result, because it's going to be just one file. The same we can do for creating and for update. In this case, I'm going to initialize a controller. I need to make this a sync. I need to make this a promise. The main difference is that in here, I'm going to do in here on the wait, I'm going to call the controller dot create, and it is going to call and request an object of type car. As you can see, I didn't have to duplicate the model. It is using the same one that I was having before. So in here, I will have to pass the body that is coming from the request, and just like that, I can, if everything works, send 201, which is telling the server that the entity was created correctly. So I have to make sure that this structure that is coming from the body actually fills this this structure, this validation standard that we created with all the properties. Otherwise, I will get an error, but we will make sure to include these things correctly. So for now, we will wait until creating the update. We will first try to make this all work. So let's compile and try this. For the server to work, the communication out before I start compiling and running this project, I will need to create in here inside of this server folder a folder that is called config. It would hold a file that in Hyperledger is called a network profile. The network profile is going to tell the SDKs what are the nodes, where are they located, so that the server can know what certificates to use and authenticate against the server. So in here we are going to create one that is called org1.networkprofile.yaml. And as you could see in the env file, I'm referencing this file already. So if I fill this with the right contents, it's going to load this to the SDK from Fabric, and it's going to make the network work. So for me to avoid typing this again, what I'm going to do is, as you can see, this is a network profile. Hurley already generated one for me, so I can take this one that we saw earlier, and I can come here and I can copy and paste the contents. I can use this one in any application that I want. It is already mapping to this specific network. Only be sure to be using the right one. So as soon as you create a new blockchain network, this file is recreated. So you should be safe to use this. But just in case you may have something older using some addresses and so on, and that may cause a problem, you need to be sure that this is actually mapping to the right setup. So let's start the server again and try to communicate with the blockchain. I will run in here npx lerna run dev, and I'm going to start this on the scope, which is my app. Since you already should have a blockchain working, otherwise you should reference to the first part of this video. What this is starting is a server for me that I can query. So I can now open Postman. And in here, I'm going to make a new request. Let's call this a test. I'm going to save this to this collection. And what I'm going to do is to reference the APIs that this server has brought to life. As you could see before, we had these routes in which it said that inside of the server in API version 1 examples, it's going to host all the endpoints. So I will come in here and I will call this at 3000, and I'm going to include this, and I will call the get all. It's connecting to the blockchain and it is telling me that there are no data in the blockchain right now, but I can take this URL and I can post a registry. So in this case, I have to post this in type raw. I'm going to tell this to use a JSON. So in the structure, I will include a testing structure. So I'm going to create in here a new car, in this case, a new model, the color, the owner as well. In this case, it's going to be me. And let's include an ID. Let's put 1 for this. What I will do right now, as soon as I send this, is create a new registry right to the blockchain, and I will get a response in here in my server. So I can go back to the first call and I can try to query this registry. And there you go. Now we have data in the blockchain. For example, I can go in here and I can try to create a second one. Let's create this second test. Again, it's going to the server and the Node.js server is calling the blockchain for me. It authenticates for me and does everything that I need to do. And there you go. We are inserting and retrieving data directly to the blockchain. I can also try to query this specific file. I'm calling by the ID. So I can, for example, query the ID1 or query the ID2. And there you go. So the only thing that we are pending is extracting the file and updating it. Well, actually just updating, if I recall correctly. So what we have to do in here is just make something similar to this one, but the main difference is that the function that we are going to call is going to be the update. So let's switch this for a promise of empty type. In here I'm going to do going to call the change owner. This is a custom function that I created for this, and what it is asking me is to send the ID and the new owner. So what I can do is I can extract the params and pass the ID and now the new owner. Let's say that we will receive also in here a body with a property which is called new owner, and we are changing the owner just like that. Instead of returning at 201, I'm going to return at 200. Let's wait until the server is ready. There you go. And now we can transfer an asset. So for example, I can come in here, I can create a new request. In this case, it's going to be 3000 API examples, but instead of a get, I'm going to send a put request with a body that is including our property, which is the new owner. So let's call it create developer. It's going to be the new owner depending on the ID that I send in here. So I can put in here the number 1. And there you go, we get an OK. So let's go back and query this user which with ID number 1. And there you go, now the owner is great developer. I can make this, try this again. Great developer seeing this video. I can update this. It is going to transfer the asset through our smart contract, and now I can query directly to the blockchain again. And there you go. We have finished creating an API for our smart contract. So this is it for this video. In the next one, I will show how to create a simple Angular application calling this API, but pretty much after this video, you can continue your journey and start using Convector in your projects. Remember to subscribe to our YouTube channel for more content like this one.